So last time we left off with inductive reasoning, and in 2.4 we're doing deductive reasoning. Deductive reasoning, pretty similar, is the process of reasoning logically from given statements or facts to form our conclusion. So compare that with inductive reasoning using those patterns. Given true statements, I can use deductive reasoning to make a valid or true conclusion. And the first way we're going to use that is with something we call the law of detachment. And what that law says is that if the hypothesis of a true conditional is true, then the conclusion also has to be true. So again, assuming that the whole thing is true, if the hypothesis is true, then conclusion is also true. So example, if I have P that implies Q, if that conditional is true, if the hypothesis is true, then the conclusion also has to be true. So when we're going to use that law, we're going to identify the hypothesis of that true conditional, because remember I need to start with a true hypothesis. And then if I have a second statement that matches that hypothesis, then I can make a different sort of conclusion. So along the same lines of that true conditional, I can make another statement. For example, if I have a vehicle that's a car, then it has four wheels. Again, the car is the hypothesis. The four wheels is the conclusion. So if I make a second statement saying a sedan is a car, that is following that true hypothesis. So then I can use that law of detachment to reach the same conclusion. This time, I'm just talking about the sedan that has four wheels. So basically, the way you want to think about this is that we start off with the true conditional. I say another statement that's more specific, and then I can make a more specific conclusion. So any vehicle is a car, it has four wheels. Sedan is a specific kind of car, so a sedan has four wheels. Follows that conditional, so hypothesis and conclusion are true. So again, you want to try these ones first before we see them in a second, but let's look at what I have underlined. If a student gets an A on a final exam, then the student will pass the course. So that's your original true conditional. And then we get more specific and say Felicia got an A on her history final. So again, that follows that first true hypothesis, so that I must reach the same conclusion. Felicia will pass the course, in this case, her history course. So trying that again. If a ray divides an angle into two congruent angles, then the ray is an angle bisector. So that's the true conditional. Got that definition from earlier. So if I say ray RS divides angle ARB so that angle ARS is congruent to angle SRB, that again is following that first true hypothesis. So hypothesis matches, and I can make a more specific conclusion. Then ray RS must be an angle bisector, because again, if the hypothesis is true, must reach the same conclusion. Last one, if there's lightning, then it is not safe to be out in the open. Next statement, Marla sees lightning from the soccer field, so since that hypothesis matches, I must also reach that same conclusion. Marla is not safe in the open. Again, you kind of think detachment just gets more specific. So looking at this with a new rule, we have the law of syllogism. So law of syllogism allows you to state a conclusion from two statements, and they both have to be true, so two true conditionals, when the conclusion of one statement is the hypothesis of the other. And the way I like to think about this one is kind of like a bridge. So if I have one statement that's true from P to Q, and then I have another statement from Q to R, I can use that statement Q as sort of a bridge that links those very first part and very last part together. So if I have P implying P implying Q, and then Q implying R, then I can link those together from start to finish. P implies R. So in our example, if it's July, then you're on summer vacation. If you're on summer vacation, then you work at the smoothie shop. So since I know in my example, if it's July, then we must work at the smoothie shop because, again, summer vacation links those two together. So trying that in our first problem, if the figure is a square, then we know the figure is a rectangle. And also, if the figure is a rectangle, then it must have four sides. So linking together, remember the conclusion of the first statement matches the hypothesis of the other. So that means that I can link the other hypothesis with the other conclusion. That means if a figure is a square, then it must have four sides. So if a figure is a square, then it has four sides. So next one to try. If we do gymnastics, then we are flexible. If you do ballet, then you're flexible. So notice both of these have the same conclusion, but the hypothesis of one doesn't match the conclusion for either one. So this we actually can't make a conclusion from law of syllogism. Remember, you need to use a statement as a bridge. So if one of your statements started with being flexible, then I could make a conclusion. But I'm just reusing the conclusion twice with different hypothesis. Can't make any conclusion. So trying that again with the last one, if a whole number ends in 0, then it's divisible by 10. Also, if it's divisible by 10, then it's divisible by 5. So I can link, again, hypothesis matching a conclusion of another statement. I can link those together to say that if a whole number ends in 0, then it must also be divisible by 5. So again, as long as I have a conclusion matching a hypothesis, I can link the other two parts together. And let's look at our combined problem here. So we can use the law of detachment and syllogism to make a combined conclusion. And statement like that would look something like this. So if you live in Accra, then you live in Ghana. That's my first true conditional. If you live in Ghana, then you live in Africa. So second true conditional. And also a statement after that. I'm not really sure how to say that. Aisa, I guess. Aisa lives in Accra. So what I can say from that, if Aisa lives in Accra, then that follows that first hypothesis. So Aisa must also live in Ghana. So we get that, again, by the law of detachment. And then if she lives in Ghana, then she must also live in Africa, following the law of syllogism. So I can combine those two and say Aisa lives in Africa. So again, she lives in Accra, so that means she must be in Ghana. If she's in Ghana, she must be in Africa. So that's our conclusion we can make, combining those two laws. Trying again with that last one. If a river is more than 4,000 miles long, then it's longer than the Amazon. And if a river is longer than the Amazon, it's the longest river in the world. So two true conditionals that we're using. And another statement after that, the Nile is 4,132 miles long. So since we know that the Nile is over 4,000 miles long, based on detachment, we know it's longer than the Amazon. And also using syllogism, conclusion from the first matches the hypothesis from the second statement. So I can also say the Nile is the longest river in the world. So that would be using both of our laws of detachment and syllogism. So that problem 4 is just there for you to give your own problem. I wrote mine, a couple there as examples. But just be a little creative with that. See if you can use the law of detachment, use the law of syllogism, and we'll check on those together in class.